So we come up with we come up with 0.692 inches squared. Again, the area of the circle you should have gotten is 8.7266. The area of the triangle, 8.034. And then you can subtract those two areas. So any questions on how you can calculate the area of a segment? Here's another triangle question. Find the area of the shaded region enclosed in a semicircle with a diameter of 10 inches. The length of the chord AB is 8 inches, and they're telling me that ABC is a right angle. So similar to what I did in the previous example, but now I've got the semicircle. I've got this triangle embedded within the semicircle. So how could I calculate the area of the shaded region? Well, can't I find the area of the semicircle? Yep, pi r squared divided by 2. Can I find the area of the triangle? Yes, and what would I do with those two areas? I could subtract them. So then the area of the semicircle is going to be pi r squared divided by 2, because they're telling me it's just half the circle. Now be careful. What is the radius of this particular circle? It's 5. Yes, be careful. It's 5. They're giving you the diameter. Now, since this is a right triangle, you can go back to that area formula that you've been using since geometry, the 1/2 base times height. Now, be careful. Remember, the base and the height are the two sides that are forming the 90-degree angle. So what I have to know about my triangle is I have to know what the side BC is going to be in this triangle. All right, because the base and the height meet at the 90-degree angle. So in order to find the area of the triangle, it's going to be 1/2 base of height times whatever side BC is going to be. How can you find side BC? Pythagorean theorem, exactly. So again, to find side BC, I'm going to do, again, the Pythagorean theorem. Because side BC is what's going to have to be plugged into that formula. So then 10 squared is equal to 8 squared plus a squared. So 100 equals 64 plus a squared. So then 100 minus 64 is going to give me 36. So what is side BC then going to be? Side BC is going to be 6. Bless you. So then to find the area of the shaded region, you're going to take the area of the semicircle, subtract it from the area of the triangle. So you guys go ahead and calculate what the area of the shaded region is going to be for me. Area of the shaded region. All right, so let's take a look at 2 more examples and then we're done. So if a gallon of paint covers 400 square feet, how many gallons are needed to paint a triangular deck with sides 65 feet, 72 feet, and 88 feet? So I have this triangular deck. And the sides are 65 feet, 72 feet, 88 feet. And they're telling me that a gallon of paint covers 400 square feet. What am I going to have to do first of all before I can figure out how many gallons are needed to paint this deck? What do I have to calculate about this triangle? The area. And what scenario do I have here? It's not a side angle side, but it's a side, side, side. So again, you're going to use Heron's area formula, which again is the square root of S times S minus A times S minus B times S minus C. Remember, S is half the perimeter. So before you use this formula, you have to calculate the S value first. So I have to take 65 plus 72 plus 88 and divide by 2. So that gives me 112.5. So any questions where I got that S value from? Again, it doesn't matter which side I call A, which side I call B, which side I call C when I plug it into the formula, because I know multiplication is commutative. So then the area is going to be equal to the square root of 112.5 times 112.5 minus 65, 112.5 minus 72, times 112.5 minus 88. Like I said, if you wanted to, you could store that 112.5 into the calculator for x. So you don't have to keep on typing in that 112.5 over and over again. So I end up with an area of about 2,302.6801, or 2. Is that my answer? No, because the question, remember, is asking you how many gallons. So a gallon is going to cover 400 square feet. So what do I have to do to this answer to figure out how many gallons of paint I need? Divide by 400. So I end up with about 5.7567 gallons. So any questions on number 7? All right, last question. So a triangular lot has sides of 120 feet and 160 feet. The angle between these two sides is 42 degrees. So let me just go ahead and draw this picture. And then adjacent to this lot is a rectangular lot. So it means they're connecting right there is the rectangle. Whose longest side is 200 feet and whose shortest side is the same length as the shortest side of the triangular lot. What is the total area of both lots? So here is my 120 feet. Here is my 160 feet. Here is my 42 degrees. I may have to readjust my picture a little bit because I know I've got a rectangular lot whose longest side is 200 feet and the shortest side is the same length as the triangular lot. So in other words, I may have to change around where this side is. Because what do I need to know in order to calculate the area of a rectangle? Area of a rectangle is what? Base times height. So what I know the base. I'm going to have to calculate this side of the rectangle in order to figure out the area of the rectangle. Everybody agree with that? So now let's use my triangle for a minute. It's a side angle side. Can I calculate this side of the triangle, which would then tell me what this side of the rectangle is going to be? Yes. So which formula can I use, law of sines or law of cosines, to do that? Law of cosines. So now to find x, remember your law of cosine formula. I know two sides of the triangle, so I'm going to square each of them and add them together. So 120 squared plus 160 squared. Minus 2 times 120 times 160. And I take the cosine of the included angle. And don't forget, I have to take the square root of that because I want to solve for x. So I end up with this side to be 107.067. So my picture is set up correctly because they're saying the side of the rectangle is the same length as the shortest side of the triangle, with this is indeed the shortest side of the triangle. So any questions about the way the picture is set up? So now I can just simply find the area of the rectangle. Remember, the area of the rectangle is base times height. So 200 times 107.067. So that gives me 21,413.303. I can find the area of the triangle, because with the given information, I had a side angle side. So when you have a side angle side, I can take 1/2 times the two sides that are given times the sine of 42 degrees. So that gives me 6,423.654. So to find the total area, because the question's asking you the total area of both lots, I'm going to add the area of the rectangle plus the area of the triangle together. And that gives me a total area of 27,836.957 feet squared.